Okay, so we go now to register used as a counter. So how does the counter works? The counter works by turning on and off input switches. Example, if the preset value of the counter is 10, then you need to turn on and off the input switches 10 times before the output energizes. So that's how the counter works. So what's the difference now between a register used as a counter and a register used as a timer? Now, as a timer, for example, if the preset value or the preset time is 8 seconds, once you turn on the input, automatically the timer starts the time, and once the 8 second is attained, automatically the output is energized. Whereas in a counter, as I've said earlier, if your preset value is 8, then you need to turn on and off the input switches 8 times for the output to be energized. So that's the difference between register used as a timer and register used as a counter. Okay, so in figure 1 here, we have an example or a circuit of an up counter. That is why you have here UC, means up counter. So input 004 here is the input switch connected to your counter. Input 006 here is used as preset, used for presetting or enabling your counter. Okay? So this is how it works. If the preset value here is 18, then before the counter starts counting, you have to turn on first input 006, meaning to say you are trying to enable the counter. So once it is already enabled, then you can now start turning on and off input 004 18 times before CR021 is energized. No? So, for example, you turn it on and then off, the up counter will start counting 1. Then again, on off, 2, until it reaches 18 counts. Okay? Again, after 18 counts, the up counter CR021 is energized. Now, if you want to reset the counter, all you have to do is to turn off input 006. Then the up counter here will be reset to 0. And then we have here the down counter. Okay, just the same as in your up counter, you have to turn on first your enable switch, which is represented by input 011. And then the input of your counter is represented by input 008. The preset value is 18 counts. So once enable is turned on, then that means that the counter is now ready to receive data coming from your input 008. So once you turn on input 008 from on to off, automatically it will start counting from 18 going down to 0, because this is, as I've said, down counter. And the output here is represented by CR022. So when you have 18 counts starting from 18 going to 0, once it reaches 0 count, then this CR022, which is the output of your counter, will be energized. So that is how the down counter works. Okay, so let's try this example here. So, figure shown below illustrates the use of combination of two counters. So you have here counter 1 and then you have here counter 2. Suppose we wanted an output indicator to go on when 6 of part C, this one here, 6 of part C, and 8 of part D. So this one here, logic 6 count, then you have logic 8 count. So if 6 and 8 are attained, then both up counter CR018 and up counter CR19 will be energized. Now this circuit would monitor the proper count. Input 002, which is this one here, this one, and input 003 are proximity devices that pulse on when a part goes by them. So input 002 here is a proximity switch, and input 003 here is also a proximity switch, no? So unsa man ang example sa proximity switch? Kana bitaw, for example, if you go to Gaisano Mall, no? Mo attempt na kay sulod sa ilahang pertahan, then there is a proximity switch that will sense you so that the door will automatically open. So parehas na nagyapon diri, you have a proximity device. Once a particular bottle, for example, enters or passes through input 002, then it will turn on the switches and then off. That will be count 1 and so on, no? up to 6 bottles. Now the same way, in your input 003, you have again a proximity switch wherein when 8 bottles, for example, passes through input 003, it will be counted properly. And all of these bottles, the 6 and the 8 bottles, will enter into your main conveyor going to its final destination. That is how this illustration works, no? So let us interpret that in our PLC ladder diagram circuit. Okay, so you have your input 001 here. Once you turn this on, CR017 is energized. What does this mean? This means that your master system is now turned on. Okay, and then since input 001 here is energized, automatically the enable here, which is also input 001 for first counter, and input 001 here on your second counter is automatically energized or turned on. Once it is turned on, that means that both counters here are now ready for counting. So when you turn on and off input 002 up to 6 times, then your up counter CR018 will be energized. Once this is energized, automatically the internal contact CR018 is also turned on. So kaning input 001 here, kaning sa imong linya diri, is naka-on po ni siya together with your input 001 here. Now, when input 003 counts up to 8 times from 0 to 8, then the up counter CR019 will be energized. Once this is energized, automatically your internal contact CR019 here is turned on, and then making your CR020, which is your final output, energized. That means that the output of CR018, which requires 6 counts, and the output of CR019, which requires, 6 counts previously, and then you have 8 counts. The total is 14. Then your CR020 will be energized.